People keep saying things like Claude Code has a great agent harness, or models are becoming commodities and the harness is what matters, or even stop prompt engineering, start harness engineering. The term sounds important and almost nobody explains it. By the end of this video, you will know exactly what an agent harness is and why it can matter as much as the model. Start with the model by itself. A language model receives text and it generates text. That is the entire interface. You ask it to write a function and it writes a function. Now, give it a real job. Open my project, understand the architecture, find the bug, fix the correct files, run the tests, open a pull request. A raw model cannot do any of that. It cannot open files. It cannot run commands. It cannot remember step 20 when it reaches step 40. And it cannot know when it needs your approval. The system that gives a model those abilities is called the agent harness. The model is the brain. The harness is everything built around that brain that turns it into a worker. A useful formula: agent equals model plus harness. Here is what actually lives inside it. First, instructions. The harness tells the model its role, its goal, its roles, and what a finished result looks like. For a coding agent, read the code before changing it. Do not modify tests just to make them pass. Run the test suite before declaring the task complete. This is more than the prompt you type. It includes system prompts, project rules, coding standards, and context injected for the current task. Second, tools. A tool is an action the model can request. Read a file, search the codebase, run a command, execute the tests. Call an API, open a pull request. The model never executes anything itself. It writes a structured request. The harness performs the action and returns the result. That exchange creates the agent loop. You provide a goal. The harness assembles the context. The model chooses an action. The harness executes it and feeds the result back. The model reads the result and chooses again. This repeats until the task is done or until the harness stops it. This loop is the difference between a chatbot and an agent. Third, context and memory. An agent may read hundreds of files and produce thousands of lines of output. That cannot all fit into the model forever. Context windows are limited, and irrelevant context makes models worse. A good harness decides what the model sees now, what gets summarized, what is stored outside the conversation, and what must survive into the next session. For long-running work, that means checkpoints, progress files, commits, and summaries, so the agent never starts from zero. Fourth, permissions. You do not want an agent with unlimited access to your computer. The harness decides which tools are allowed and when a human must approve. Reading a file is automatic. Running the tests is safe. Deleting a database, spending money, or deploying to production waits for a yes. The harness can also place the agent in a sandbox, so generated code cannot reach your credentials or the rest of your machine. The harness makes the agent capable. It also limits what the agent is capable of. Fifth, validation and recovery. A model will confidently declare a task finished when the result is wrong. A strong harness does not trust the final answer. It runs the tests, it runs the linter, it checks that the application starts, it inspects the diff. For risky changes, it asks a human to review. When a command fails, the harness feeds the error back and lets the model try again, with a retry limit, a checkpoint to restore, and a path to escalate to you. 6. Observability. The harness records everything, every tool call, every result, every token, every failure. These records are called traces. Without them, a broken agent is a mystery. With them, you can see whether the failure came from the model, a bad tool description, missing context, or a broken API. Here's the point that changes how you compare AI products. The same model performs very differently inside different harnesses. Put one powerful model inside two coding agents. The first gets vague instructions, poor search, a context full of noise. and it never runs a test. The second gets clear rules, only the relevant files, a sandbox, and it checks its own work. The second agent feels dramatically smarter. The model did not change, the harness changed. Asking which model a product uses is only half the question. The system around the model matters just as much. Three terms get mixed up. A framework is a developer toolkit for building agents. A runtime is the infrastructure that executes them. The harness is the configured system around one particular model. Its instructions, its tools, its context strategy, its permissions, its loop, and its recovery rules. And MCP is not a harness. MCP is a standard way to connect agents to tools and context. A harness can use MCP. It is one cable, not the machine. So harness engineering means improving everything around the model. Does the agent have the right tools? Is the context correct? Can it recover from errors? Does it verify its own work? Are dangerous actions protected? Can you see why I failed? Can it continue tomorrow where it stopped today? As models get stronger, building a useful agent stops being about picking the smartest model. It becomes about designing the environment the model works in. The next time you watch an AI tool read files, run commands, fix its own mistakes, and ask before doing something dangerous, remember what you are watching. The model provides the intelligence, the harness turns that intelligence into reliable action.